Hello humans. All right, here we are in Code with Connor. We're going to be looking at AP Computer Science stuff, Java stuff. We're looking at recursion today. So we're going to do a little mini lesson on recursion and talk a bit about what it is and how it works. Let's jump into some code and start there. Okay, so here I am in my class. Let's just go over briefly what I have. I've got a my program file, my program.java, which has a main method. And then I have a non-public class inside that same file. You can do multi-classes in the same file. You just can't have multiple public classes in the same file, which is fine. Again, if you wanted to have a separate file, do that. So this just can be my main where I'm going to make objects and stuff. In my recursor class, we're going to talk about this function here. We're going to talk about this method here, the factorial. Now we already know how to do a factorial. Okay, so 5 factorial is 5 times 4 times 3 times 2 times 1. It stops at 1, because if we times by 0, then the whole thing's 0. So obviously we don't want to do that. So the idea here is using recursion in order to do that. So what is recursion? Well, I'll show you just right here. Inside of our factorial method, you can see that there is a call to the factorial method. This is creating what's called like a recursive stack or a recursive set of calls. When you are calling the function from within the function, essentially what happens is the first call can't end until all the nested calls have ended. Kind of imagine a set of like Russian nesting dolls, right? If you were to take them all apart and you keep taking the tops off, you can't put the thing back together again unless you close each of the inner pieces of it. And then finally at the end, you put the outer top back on. It's the same idea. As soon as you open that recursive box by doing a function call from within itself, you have to let all of those inner function calls resolve themselves before your kind of outer function ends up being able to end. Okay, so this means every time we do recursive functions, we have to make sure that there's what's called a base case, which means there has to be a way for the function to fully execute without calling itself. If that doesn't exist, if there's no way for the function to end without calling itself, then you'll end up in an infinite recursive loop. Because if not, you'll end up in a recursive infinite loop, which you don't want, okay? So let's look and find our base case in this factorial method. So we have if n is not equal to 0, return n, so our current value, multiplied by the factorial of n minus 1. Else, so in this case, look at our precondition. Our precondition said that n has to be greater than or equal to 0 coming into the function. So if n is not equal to 0, then it's anything above 0. Else should really just be the condition of if n is 0. So else return 1. And you'll notice this line of code can execute without ever triggering another call to the factorial method. And because of that, it's our base case. So when n equals 0, we are going to return a value of 1. Okay? That's going to be our base case. Got it? So let's code trace this a little bit so we can see what's going on. Don't mind my handwriting, it's terrible. So let's say we wanted to do 4 factorial. Okay? So we're going to pass 4 to the first call of factorial. So 4 is going to come in here for n. So n is not equal to 0. So we're not running the else, we're running the if. N's value is 4, so you can see that there. And it's going to do 4 times by, but then it's going to start a new call. And it's going to pass a 3, and we're back calling the function again. Okay, so now this is a 3, which means n is not 0, so this is a 3, this is not happening. Now we're going to call it again on 2. Scroll down. So now we're calling it again with 2. N is not 0, so this is 2. This is not happening. We're going to call it again with 1. Okay, come down here. This is now 1. Okay, which means n is not 0, so this is now 1. And we're going to call it again, this time with 0. 0 is going to come into the function. N is not equal to 0. That's not true anymore, so that's not happening. So we are going to run the else, which means we're going to return 1. Now we need to trace backwards on the returns. Where does this 1 go? This 1 is going to track up here, and all of this is going to get replaced with a 1. So now it's gonna do 1 times 1, and then that's gonna get returned. So it's gonna return 1 times 1, which is 1. And that's gonna come here and replace this whole method call. That's a 1. Now it's ready to return this one, so it'll do 2 times 1, and it'll return that 2 value. So this whole factorial is gone, replaced with 2. 3 times 2 is gonna return 6. So this whole factorial is gone, replaced with 6. 4 times 6 is gonna get returned, and we're out. This whole thing is 24. So this is the idea of that recursive stack, okay? Some people like to think of it kind of like nested, like square bracket style. I'll show you that as well. So when we call factorial 4, it does 4 times by fact 3. Fact 3 goes again, which is 3 times fact 2, okay, which runs its code, which gives it 2 times fact 1. Fact 1, which runs its code and does 1 times fact 0. Fact 0 returns 1. Then this returns 1. This returns 2, which returns 6, which returns 24. So there's a couple of different ways to visualize that nested idea. But the idea with recursion is you have to have that base case. Okay, without the base case, infinite recursion happens, bad things happen. You also have to make sure that you can reach your base case. So if we had just called factorial n within our function, within our method, then the value would never have been going down, which means it never would have reached our base case. Or if we had called it on a negative n to start, it would have just kept going down forever, never would have reached the base case. So it's both having a base case, but then also ensuring that our code allows the base case to be reached. All right, that's it for the teachy bit. Let's jump over and just kind of look at some code examples of recursion. So we've already looked at our factorial example. Okay, so if I run my code and show you what it looks like, there it is. And I know it's small, I'm sorry, I can't make it bigger on CodeHS. 4 factorial is 24. Cool, so that works. So a couple other functions that work well with recursion that I'll show you. One is a sum function. So you can see it here in my code. So precondition is k is greater than or equal to 0. So it takes one integer, okay? Doesn't need to be static here, ditch that. So if k is greater than 0, then it returns k plus a recursive call to sum with k minus 1. Very similar to what we saw with factorials, but with a plus sum. And then else, which would mean k would be equal to 0, we return 0. Now the reason we couldn't return 0 in the last one is because it was multiplicative. If we returned to 0, the whole thing would be 0. So we needed our base case to return 1, right? So this is almost identical code with summing. So let's consider that for an example here. So let's do int n equals 10. Okay, so I have int n is 10, result is now mr.sum of n, print out the sum of all integers up to n equals, and then the result. So let's run this and see how it works. The sum of all integers up to 10 is 55, 10, 19, 27, 34, 40, 45, 49, 52, 54, 55, and it works, okay? So that was one example. The other one was a sum that takes 2 parameters. So this one takes a start and an end value. So we obviously want the end to be bigger than the start, and we need them both to be positive. So we need start to be greater than or equal to 0 and end to be greater than 0. And the idea is it sums all the integer values between the two. So if end is greater than start, then we still have some room to go. So then return our end value plus the sum of our start and n minus 1. So ticking in 1. So essentially if we did like from 2 to 5, it's going to start at the 5 value. It's going to hang on to that. Then it's going to call it again from 2 to 4. It's going to hang on to the 4, and then call it again from 2 to 3. Hang on to the 3, call it again on 2 to 2, get a base case, then back up to the 2 to 5. Okay? So call with the end stuck in our current function and the sum start to n minus 1. And then else, so once end and start are equal, we just return that end value. So whatever that final value is, which will now be equal to start as well. So we can see, like if I called it on 2, 5, it would start here with 5 is greater than 2, keep the 5, call it again from 2 to 4. Okay, keep the 4, call it again from 2 to 3, keep the 3, call it again from 2 to 2. 2 to 2 is going to return 2, and then it's going to be 2 plus 3, and then it's going to be that answer plus 4, and then that answer plus 5, and then we're going to get our result. Okay, so we can do this thing again. Let's do n1 is 2, int n2 is 5. Okay, I got this all typed out. n1 is 2, n2 is 5. Call it on the double variable. Okay, this is overloaded. And then n1 to n2 is the result. And there we go. Sum of all integers from 2 to 5 is 14. Okay, 2 to 5, 2 and 3. So let's go the other way because that's where the code goes. 5 plus 4. Okay, actually the code does go the other way. So we go 2 and 3 is 5, and then another 4 is 9, and then 5 is 14. Hey, it's working. Okay, it's just a couple of examples of that recursive piece there. And I'll share a snippet of this code in the description of the video so you can go check it out if you want to kind of explore it and play with it a little bit. But that's the idea of recursion. And I realized that one of my print lines was cut off in the video, but you know what? You got to be able to concatenate strings on your own. If you're doing a lesson on recursion and you're stressed out about how I printed variables with strings together, you might want to go back and learn that. No offense. Don't shoot me. Okay, so I'll share that code so you can have a look at it a little bit more, but this is the idea of recursion. Just use recursion with intent. Use it, in a way that's going to help you. Always remember the base case and always make sure that your code has a way to reach the base case. That's super important. All right. Thanks for watching. See you soon. Bye, humans.